Alright guys, welcome to another lesson in Science 10 here. This is Mr. Adamson, and in this exciting lesson we are going to talk about describing displacement and velocity quantitatively. In other words, I'm going to show you what the definitions are. I'm going to show you how to use the formulas, and yeah, that's about it. This is a video lesson of the hard copy of notes that you can also access off the main Google Doc there. Just look right here, words in blue and red represent links to sites with great information and practice questions. So make sure you're looking at the hard copies of notes there and you press on the links, and you'll see as we go on through here what is linked. Now before we start anything though, we need to know a few terms. We need to know the definitions, and these will be on your word walls, and these are important things to know. Now the first one we're going to talk about here is distance. Now distance is a scalar quantity, and I'll get back to you what a scalar quantity is, but it's a scalar quantity that refers how much ground an object is covered during its motion. Now we have a nice little picture right over here, and if we look, let's say our starting reference point is right here, and so we are going to look at the purple line and we're going to talk about our distance, and we're going to go all the way around here to this point. So we start at our reference point and go all the way around. Now the distance again refers to how much ground an object is covered during its motion. So how much was this? What was the meters of that? Now again, it's a scalar quantity, and scalar refers to how much size do we have. So scalar is size, or another word for that is magnitude. Magnitude. Alright, so that's the definition of distance. Now the next term we're going to talk about is displacement. So we have displacement right here, and displacement is a vector quantity that refers to how far out of place an object is. It is the object's overall change in position. Now that is really important. It's the object's overall change in position. So if we look here, so again, here's our starting reference point, the school, and we have a distance that is going to, or that would be a person walking all the way around here, and they'd finish at the shop. Okay, that's what we were previously talking about, the distance, but we want to talk about the displacement. Now the displacement is how far is it actually away, not how far you actually traveled. So again, if we're looking at the start of the school here, how far directly across is it? And again, it is the object's overall change in position. Okay, not how far we traveled along this line here. So that is a big difference between displacement and distance traveled. Distance travel is, how far did you actually walk? You zigzag, calculate those meters. Displacement is how far am I actually from that point. Now, again, it is a vector quantity. So we can see vector quantity here, and that means we have size and a direction. So when you're expressing your answers, when you're doing it, if we look here, if we say this way up is north and this way is east, we know that this person here along their displacement traveled northeast. Now another cool thing to look at would be, say you were running a 400-meter race around a track. We have a little person here and he's going to begin running. So this is 400-meter track. So he starts running all the way around the track. Now distance traveled wise, that is 400 meters. But displacements wise, if we started right here and we go all the way around and end in the same spot, our displacement is actually 0 meters, because we are again the object's overall change in position, and we have, if we started here, we have not actually changed our position. We are still back at the same starting point. Now this slide, just the picture, but again, if you're on the actual hard copy of notes, it's another YouTube video with a great explanation of the difference between distance traveled and displacement. Now the next term that we need to look at is speed. So what is the speed? And again, if we look at the definition right up here, speed is a scalar quantity that refers to how fast an object is moving. Now speed can be thought of as the rate at which an object covers distance. And we have our nice little formula here. So average speed is distance traveled and time taken. And you're going to see lots speed, which is just v, equals d over t. So distance traveled over time taken. Relatively straightforward. But the important thing here is distance. We need to use the distance, not the displacement, the distance. So how far did they actually go? So if we have a little person who is walking along a path here and they go 5 meters that way, and then they go another 10 meters that way, and they stop, and then they walk back another, say, I don't know, 10 meters this way. What is their actual distance? Well, our actual distance is 5 plus 10 plus another 10 would be 25 meters. So that would be the number that we would use right up here, 25 meters. How long did it take that person? Say it took them, I don't know, 3 seconds. Okay, calculate that out and we would get an answer in meters per second. The last term that we need to know about is velocity. Now velocity is a vector quantity, so again vector means we have size and direction, that refers to the rate at which an object changes its position. Now where have we heard that term before? Where have we heard change its position? Well, that's right, if you see right over here where it says displacement, we heard that in the definition of displacement. What was its actual distance relative to its position? So with distance traveled you're using, or with speed you're using distance traveled, and with velocity you're using displacement. So average velocity, and because again it's a vector quantity, is going to equal displacement over time. So two relatively very similar looking formulas, very similar looking terms, but again a lot of difference. So when you're calculating out questions, you got to make sure you know what you're looking at, and what you got to calculate out. And the last slide here is just again another YouTube video. It goes through some practice problems. It's a great explanation of how to calculate things. I really suggest you go to the hard copy of notes and watch that YouTube video. And at the end, or on the main page also, there's a link to some more practice problems. I really suggest you do those to get familiar, because speed and velocity are very basic level formulas in physics, but they are what starts everything and how you progress off of them. So please look at those things, ask your teacher if you need help, but thanks for listening.